Hi and welcome back to another lab on module number 14. As you know that module number 14 is about building serverless architectures and microservices. So this is an optional lab, which is a guided lab, but we'll try to understand that what are we doing in this one. So this guided lab is about breaking monolithic Node.js application into microservices. So just in a nutshell, first try to understand what we are trying to do in this one. So in this lab, we'll start with the traditional monolithic Node.js application and progressively refactor it into microservices, deploying those services using Amazon ECS, and finally see how breaking apart applications can make them more scalable, maintainable, and resilient. Towards the end of the lab, we'll have hands-on experience and we'll have understand the containerization of the applications, pushing it into the Amazon ECR and creating ECS task definitions and applying microservices on AWS Fargate. So pretty lengthy lab, and there are lots of steps involved in this one. If you'll see, I think that's the longest lab that I have seen so far. It has around 6 tasks, and then they have separate subtasks in this one. So we'll try to finish it, but just keep an eye on the timing over here. There is a high probability that your lab would end, and if the lab ends, everything would be reset. So just make sure that if you are approaching that you are finishing 3 hours, just click on start lab again so that it would refresh the timer over here to 3 hours again, and then you can continue working on it. So let's get started and briefly go through what is required over here, but I'll continue by step-by-step process as we always do. So I'm going to start working through task number 1 in this one, and as you can see that the task number 1 is about preparing the development environment. So in this step, we'll prepare our development environment, we'll set up necessary folders, clone the lab files, and make sure that our workspace is configured to run Node.js application properly. After completing this step, we'll have a clean and ready environment for running our sample monolithic Node.js application. So let's get started. So first in this one, we are going to search for Cloud9 as we usually do for integrated development environment. Once that's open, we are going to open our integrated development environment. It would open an interface like that. So since we'll be working in the terminal, which is a bash terminal, so we'll go back to our instructions manual, and they are saying to go to your Cloud9 ID and then copy this code, and we are going to paste it here and press enter. So what are we doing over here is that we just downloaded the compressed archive files containing the lab files and extracted them in its contents on AWS Cloud9 environment folder. So the downloaded files are downloaded and extracted, which is available over here. So it downloaded the files, extracted them, and created a folder which you can see on your left hand side. So let's try to understand what's there in these folders. So in the first folder, this folder contains the files related to the monolithic implementation of the application intended to run directly on our Node.js server. Then on second one, which is containerized monolithic, this folder contains the files related to the monolithic implementation of the application intended to run in a Docker containerized environment orchestrated by Amazon ECS. And then lastly, on container number 3, this folder contains the files related to the microservices implementation of the application intended to run the Docker containerized environment orchestrated by Amazon ECS. Now we'll see what's there in task 2. So task 2 is about running the application on a basic Node.js server. So in this step, we'll start working with the provided monolithic Node.js application and run it locally on a simple Node.js server. This will help us in understand how the application currently functions as a single unit before we refactor it into microservices. So if you read the instructions for this one. They're saying to check the environment, that we have a command line HTTP request, and then we have Node.js, and under that we have users, threads, and post, and it appears both for the worker node. So we'll install Node.js and stuff, and then they're telling us that how to install it. So in 2.1, we are installing the Node.js module. So in this step, we'll install the necessary Node.js module listed in the projects package, which is a JSON file, using the npm install, and we did it earlier. So after completing this step, all dependencies required by our application will be available in the Node modules folder. So in order to run the commands, I'm gonna copy the commands from here, and then I'll go to my console and I'm gonna paste the commands over here. And as you can see that it has downloaded all required files. If you want, you can type in npm audit as well to check the details of this one. And they are saying that the report says that there is an update, a minor vulnerability, and we can fix it. It's a test lab, which is an optional lab. Up to you if you want to do it. We can continue it like this as well. But still, I just fixed it and it showed me that now there are no vulnerabilities. Now we'll start working on task 2.2, which is reviewing the application and design and the code of it. So we'll review the source code and understand the monolithic structure, including the routes, data handling, and how different components interact. So these are the instructions for that one. So let's go back to our console. So they're talking about one container and the folders under it. So first of all, they're just explaining that what is under node module. So this folder was created when you installed the required JavaScript module in the previous subtask, and contains their source code. Likewise, they're just explaining all of them, so you can read it from the instructions manual to get a better understanding of the files which are saved in this package. We are jumping right next to task number 2.3, which is running the application. So we'll start the Node.js application using the appropriate npm start or node command. So you can copy the command from here and then paste it here. Now as you can see that it created the file and started the application here. But as you can see that it threw an error over here. Now in order to fix that one, I can pass in a command to remove the KOA, and then I would try to start it again. So I can type in a command to remove it here, and then I can pass the second command to fix the packages and stuff. And then again I can try to start npm start, and as you can see that it has fixed the error and it has started the service. Now try to understand what we are doing here. The server is started and the application entry point, which is index.js, is started. That's the first time it is invoked index.js, which creates two cluster threads, which is a leader and worker to process the requests. So we worked on it. Now they are saying to open a new terminal and run this command over there. So you'll keep this bash terminal open, click on this one and open a new terminal here and paste the command that they are saying in this one. So this is a script which would contain a list of users in the message board database. After that, they're saying to copy and paste this command. So we'll paste it here and press enter. Likewise, there are two more commands on your instructions manual. Copy and paste them here as well. Then they are saying to go back to this one, and now we can press Ctrl C to stop the server that we started earlier. So now we'll start task number 3, which is containerizing the monolithic for Amazon ECS. So in this task, we'll containerize our Node.js monolithic application so that it can be deployed on Amazon ECS. We'll write a Docker file, build the image, and then push it to Amazon Elastic Container Registry, which is ECR. And after that, we'll start working on preparing the application for Docker containerization. So we'll be creating a Docker file that would define how our application is built and run inside the container. And after completing this step, we'll have a Docker file with a proper configuration for our Node.js dependencies and startup commands. So for this step, they are asking us to go to second folder for containerized monolithic. And we'll click on this one, and then under this one, we'll find a thing called package.json file. You'll double click on that one and it would open the file, so you'll have to slide it down here so that you can see the dependencies and the information which is inside. So they are just asking you to notice this thing on line number 7 that the entry point into the application has been. So just follow the instructions which are there and try to understand the file. After that, we'll go to Elastic Container Registry, and under this one we are going to click on create repository and then type in MB repo. We are not making any other changes over here, and click create. Now it's very important to copy the URL from here and paste it on your notepad file. Then on 3.3, it's asking us to build and push the Docker image. So we'll build the Docker image locally using the docker build command, and then we'll push it to the ECR repository using the docker push. So in order to get the commands for that one, we'll go back to our repositories, and once you'll click on this one, you'll be able to see the push commands here. Now there are for Windows and Linux, but since our platform is Linux based, so we are going to copy these commands and then we'll run them one by one. So with the first command, we'll copy it from here, then we'll go to our IDE environment and paste it. Then they are saying to run this command as we ran the first command which was there on our Linux module with IDE environment. Now here we'll run the command as mentioned there, and then we'll run all of them one by one. So I'll copy the command number 2 first, and it would go in here. Then I'll copy the third command and paste it here, and then the fourth one and just paste it there. Now we'll return, press close, and we can refresh it. And even if we'll go back to our Elastic registry, click on this one, go to repositories, you'll be able to see, and the latest one with its details inside. Now we can copy this URL from here and keep it as a reference. So now we are starting our task number 4, which is deploying the monolithic to Amazon ECS. So we'll deploy our containerized monolithic application using Amazon ECS. We'll create a cluster, define the container task, and launch the service. After that, we'll start 4.1, which is creating an Amazon ECS cluster. So we'll create a new ECS cluster using the management console or command line interface using a Fargate as the launch type. So that's what they're saying. The things which are important in this one is that you can copy these things, the names, etc., that we'll have to paste it on our Amazon console for the clusters and etc. So I'll note it down on a notepad file and we'll start working on the exercise. So as they are saying to search for Elastic Container Services, so again we'll go to our search and we'll select this one, and I'll again open it in a new tab. So it would open here, and we'll deploy a containerized. So we'll click get started, create a cluster, and we'll replace this cluster name with the name which is provided in the instructions. Next, they're saying to configure the infrastructure for this one. So we'll select this option over here, and now we'll have to select the instance types. We'll select Amazon Linux 2023, keep it on demand, and here they are saying to select T2 medium. So if you can't find it, you can type in here T2, and then you can select this one, which is T2 medium. Change the minimum and maximum capacity as 2. Then we'll scroll down, and under network settings, select this one, and we'll select lab VPC. And just make sure that you have both of them selected as public subnets. After that, we'll scroll down and we'll go to the security groups. And in this one, we'll select this one as ECS SSG. Select that one and uncheck the default one. After that, we are not making any other changes over there. Just click on create. It would take a while. Once it's ready, you can click on this one, and then as you can see that the infrastructure and configurations are updated. So if we'll click on infrastructure, you can see these two container instances over there. And if you'll click on configuration, it is still loading the settings for that one, and it would show its cluster name and the CloudFormation stack details. So we have completed this step. We checked the infrastructure and these two instances. Now we'll work on task number 4.2, which is creating a task definition for the application container image. So we'll define the task configuration for our container, including the memory limits, port mapping, and environment variables. So for that, we'll go to our clusters, and in the same one, we are going to click on task definitions over here. Create a task definition and click on this one, and we'll enter the name as MB task in task definition family. Under the infrastructure requirements, we'll uncheck this one and select Amazon EC2 instance. Under CPU, they're saying it should be 0.5, and for the memory, we'll have to change it to 1 GB. Next, in the task execution, select create new role, and then for here in container number 1, we'll enter MB container. Now if you remember, we copied the image URL earlier. We'll paste it over here. Under container port, we'll enter 3000. After that, we are not making any other changes, and just press create. Once that's done, we'll go to our task number 4.3, and 4.3 is about creating and deploying a service. So we'll create an ECS service that uses our task definition and runs one or more container instances. So we'll create a new service, and then we'll change the environment variables for that one, copy these details, and let's start working on it. So we'll come back to our Elastic Container Services, click on Task Services, click on the one that we are using, and then we'll have to, and here we'll just go to Deploy and create a service. Here again, like we did earlier, we'll change the service name to MEECS service. This information is there on your instructions manual. Then we'll go to launch type. We'll select the option under compute configurations as EC2 over here. Then we'll go down to networking and just make sure that your public subnets are selected here. Your lab VPC should be here. And under the existing security group, we'll select the SG1 and uncheck the default one. Then we'll scroll down, go to load balancing, use load balancing over here. Just make sure that you have application load balancer selected over here. and then we'll select the option create new load balancer and enter the name MB load balancer. Under the target group name, we'll enter MB target. And after that, there are no more changes. Just click create. Now you'll have to give it some time. It would take around 5 minutes before everything is deployed. And then you can click on MBS services. And here even you can see the status of it as active and it's running. And if you want to see the load balancer health, since it's already running on port 80, you can click on this one and check it over here. Now if you want to see the DNS name of the load balancer, you'll have to go to configuration and networking, and you'll scroll down to find the DNS name over here. So you can copy it, and if you want to open it in a browser, you'll click on it and it would show you a message that it's ready to receive requests. So in next task, they are saying to test the containerized monolithic. So we copied the DNS name. Now they are saying to add these things after the DNS name, and we'll be able to see it on their website that what's the status of it. So I copied the URL for the DNS name of our load balancer. So what I can do is that I can copy all of them on a notepad file, and then I'll come here, I'll paste it, and then I'll replace the first part of it so that I can easily check the URLs and the status of it. So for the first one, it's saying check the API. So now I'll go on my DNS for load balancer, and once I'll enter the API, it would tell me that API is ready to receive requests. For API users, it showed me a list of users, and if I'll paste for threads, it showed me the information related to that. And the last one which they showed us is this one, and it would show a text similar to this one. So just a reminder to click on Start Lab again to reset the timer to 3 hours again. And we are on task number 5, where we are looking at refactoring the monolithic. So in this step, we'll break the monolithic Node.js application into smaller independent microservices. Each service, such as users, posts, and threads, will be separated into its own code base and container. After that, we'll work on reviewing the refactored microservices application. So we'll review the provided microservices code base to understand how functionality has been separated by the business domain. So there are set instructions for that. We'll have to go in the threads and users to see those things. So let's start working on it. So we'll go to our IDE environment, click on 3, and they're saying check these 3 things, that now you have posts, you have threads, and you have users. After that, we'll check 5.2, which is provisioning an ECR repository for each microservice. So we'll create separate Amazon ECR repositories for the users, posts, and threads. Further, we'll be looking into microservices of it as well. So as they are saying, go back to your console and search for this thing, and then on the repositories, we'll create a new repository and we'll name it as MB users repo. So here we'll search for container registry, open it in a new tab, and we'll have it here. After that, click on create repository. After that, we are not making any other changes, just click create. So we have MB users. Now we'll have to create similar for threads and posts. So I'll copy the same one. So I'll type the name as MB threads repo, create, and then create another one and name it as posts and create. So you'll have total 4 over here. We created the threads, users, and posts here. Once that's done, on task number 5.3, we'll be building and pushing the images for each microservice. So we'll build a Docker image for each microservice, users, posts, and threads, and then push them into their respective ECR repositories. Then once that's done on 5.3.1, we'll be building and pushing the image for the users microservices. And in this one, we'll build the Docker image for the user service and using its Docker file and push its corresponding things to ECR repositories. So we'll copy the command from here, go back to your command line interface and paste the command over here, and then go to your ECR, and in this one we are going to select users and then click on view push commands, and in this one we are going to copy the first one and then go to your CLI and paste this one. Likewise, we'll copy all of them one by one and paste it over here. So I'll copy all of them on a notepad file for me for easy reference. So create a notepad file, copy the second command, then the third one, and finally the fourth one. So I'm copying it on my notepad file. Now I'll go back to my command line interface. I'll paste the second one here. Then I'll copy the third one and paste it here. And finally I'll paste the fourth one here and press enter. And then if you'll go to repositories of your users, you'll be able to see image latest up here, and if you'll click, you'll see the URL and the digest details in this one. So they are saying to copy this one and keep it on your notepad file, so I'll do that and paste it on my notepad file. Now in next steps, they are saying to perform the same operations on threads and posts. So we finished the part for users. Now we'll have to perform the same operations for threads. So we'll copy the command from here, paste it here, press enter, then click on threads, view push commands, copy all of these commands, and now let's run it one by one. So this is our first command. Then I'll copy the second one and paste it here. Then I'll copy the third one and paste it here, and finally I'll copy the fourth one here and paste it. Then we'll come back to our ECR, close it. If you want, you can refresh it. Now I'll open threads. I have images here, open it and copy its URI as well. So after completing threads, we'll go to posts and we'll copy this URL from here, paste it on our command line interface. Then we'll go to our repositories again, and this time we'll select posts here. Rather, go back, select posts and click on push commands and copy all of these commands first. After that, go back to your command line interface and paste the first one. Then I'll paste the second one, then the third one once that's done, and finally the fourth one. So once that's done, we'll go back to our services, refresh it, open posts. You'll be able to see latest in this one and copy the URI. Now we are starting task number 6, which is about deploying the containerized services or microservices. So we'll deploy our containerized microservices on Amazon ECS. Each microservice will have its own task definition and ECS service. And then we'll start working on creating a task definition for each microservice. And in this one, we'll create the post, threads, and microservices. And then in 6.1.1, we'll create the task definition for specifying the image, CPU, memory, and container port, etc. So just keep an eye on one thing, just like we did 3 different tasks for the users, threads, and posts. We'll be repeating these 3 steps. So I'll go very fast. I'll just explain the first one, and then I'll briefly complete the others to complete task 6.1. And after completing it, you can see we created a load balancer earlier. Then we worked on user, target group, post, and threads. Then we'll work on the cluster things for the user container and threads and post. And likewise for your users, post, and threads would be here. That would push the image for your ECR users over here. So we'll go to Elastic Container Services, and we'll click on task definitions here. Now we'll create a new task definition, and we have the name provided. So we'll copy first for the users, and we'll start working on the users task. After that, as we did earlier, uncheck this one, select EC2. Here, change it to 0.5 and change the memory to 1. Then go down, write the name as MB user container. Next, in the image URL, now you remember we copied it earlier. So if you have maintained the nodes for this one, you'll be able to copy the one that you copied for the users from here and paste it in this one. Else you can browse the ECR images and select it from here as well. The only other change is we'll change the port to 3000, and we are not changing anything else. Just click create. Now once that's done, we'll start working on another one. Create a new task definition. Let's do it for posts. Here also we'll select EC2 instance, here 0.5, and then here also 1 GB. Scroll down for container number 1, enter MB post, and don't forget to enter the URL for posts. So I'll copy it from my notepad file and paste it over here and click create. Now again, let's go to task definitions, create new, enter this one over here, select EC2 instance, change it to 0.5, change it to 1 GB, and then here we'll name it as a threads container, and we'll copy the URL for threads and paste it over here. Port here as 3000, and now press create. So now if we'll go to definitions, you'll see these 3 over here with users, threads, and task, and the status of all of them is active. Now we'll work on 6.2, which is creating and deploying the services. So in this one, we'll deploy each microservice as a separate ECS service within the same cluster. So we'll be going to the clusters of this one, and then we'll follow the users and deploy the services, and likewise we'll be working on posts and threads. So we'll go back to our ECS and we'll click on clusters here, and then click on the cluster that we created earlier, and here we are going to create separate clusters for posts, threads, and users. So in the first one, we'll select users. Under the service name, enter MB user service. Then on launch type, we'll select EC2, and then we'll go down and then look for networking. Click here, make sure that lab VPC is selected. After that, your subnets should be public subnets, And after that, I'm going to select the existing security group, which is this one, and unselect the default one. Then we'll go to load balancing, select use load balancing. We'll keep these settings as it is, and then we'll use an existing load balancer. And here we are going to select internet facing load balancer. Here use an existing listener, select 80. And the target group name should be MB user. Just make sure that there are no spaces after this one. Under the path, I'm gonna enter users priority 1, and we are not making any other changes. Just click create. Likewise, we'll be creating for posts and threads as well. We'll go for post task, and here also we'll name it as post service. Then we'll go down, use launch type, select EC2, and in this one also we will be making the changes in networking. Make sure that subnets are again public. Select from the security group, second one, uncheck first one, then go to load balancing and select load balancing over here. Now in this one, container, use an existing load balancer, select the load balancer which is here, use an existing, name it as 80, and select a target group. So the target group for this one should be MB posts, and the path for that one should be this one, have the priority 2 over here, and create. Now that's our second. Again, click on clusters, again this one, create a new one, and then I'm going to select the last one as threads, and I'm gonna name it as thread service over here, then launch type, and then select EC2, and then we are not making any changes here. Networking, again public subnets, use the existing group, uncheck this one, and then go to your load balancer, use existing load balancer, and choose the load balancer and select the port, and then name the thread as MB threads target. And for the path, I'm gonna select this one, and I'll put the priority 3 in this one and create. Now they are saying return to clusters and look at the view load balancer and listener rules and check these options over there. Now you'll have to give it some time and see that all of them should be green with tasks running for all posts, threads, and users. Now while clusters being selected, we'll go to the first one and you'll be able to see the health status of it. It's listening on port 80, and then if you'll click on task, you can see that it's running, and for logs and deployments can be checked over here. Now we'll go to our EC2 and then click on load balancers and click on the load balancer over here, and you can see the listeners and rules. And if you want to see the networking map of it, you'll be able to see further on the resources map. You'll be able to see the status of it and the proper mapping of it. But we are more interested in the listeners and rules, so we'll click on this one, and as you can see that all of your 3 users, posts, and threads has been listed over here. So it means that the requests are forwarded to the respective groups, and a default role forwards the request to the MB target that was created before refactoring. So you modified the rule to provide a different invalid request message in case the request does not match the desired URL. Next, they are saying to choose default action and edit the rule. So we'll select our last one, which is over here. Then on actions, edit rule, and then select forward to target groups, and in this one select the user's target group. After that, just save the changes. Now, as you can see that this thing changed over here, it means that the new rule as per the settings is that all requests are routed to MB user's target if the request parameters are not specified. Next, they are saying to go back to the clusters and make the modifications on services and update the rules. So we'll go back to our ECS, click on this cluster, and now we are going to select this one and click on update. Here we are going to change the desired task as 0, and after that hit update. And if you'll go back to the services or the clusters for this one, you can see that it's updating it since we changed the configuration of it. Then on 6.3, they are asking us to validate the deployment, and we can validate it by typing in the following URLs after our DNS name. So what I can do is that I can copy all of them. I'll modify the URL and we'll test it in our browser. So we'll paste the first URL with /API. It would show us an output for this one. For the second one also, it is showing an output. For the third one, again, we'll be able to see an output. And for the fourth one also, it's showing us an output. So with that, we have successfully completed this guided lab. So we learned that how can we start a single tier monolithic Node.js application, containerized it, deployed it, Amazon ECS services, and then refactored it into separate microservices for users, posts, and threads. By doing this, you experience the real-world benefit of microservices architecture, independent deployment, scalability, and better fault tolerance, all running into a serverless Fargate environment. So that's it for today. Thank you very much.